A warm welcome to JTM. I've got these 4 questions for you. You may find these types of questions in your pre-calculus exam papers. If you think you can't answer them, or if you're not feeling too confident, then this is the perfect video for you. I will be going over any techniques, laws, rules, or properties that would help you most in answering these types of questions. In case you should find them in your own exam papers in the future, you'll know exactly what to do. So here we go. So our first question here requires us to find the domain of the rational function r of x equals minus 3x squared over x squared plus 6x minus 16. Now I noticed an important keyword here, domain. If you will remember, domain is all the x values of a function. So we want to find all the x values that will satisfy this function. Now when I think of domain, I think to avoid these 2 situations. Division by 0 and square root of any negative number. Now there is in fact a division going on here, which means we are going to want to avoid division by 0. Now how exactly do we do that? To find where division by 0 occurs, I would have to look at the possible x values where x squared plus 6x minus 16 equals to 0. So let's write that out. Now there are a few possible ways we can solve this equation, of course. There is factoring, there's the quadratic formula, and there's completing the square. This looks to be factorable, so let's go with that as it is the quickest way. So we'll have 2 brackets with the leading term of x. Now I want to find the 2 factors that multiply to give me minus 16 and add up to give me positive 6. Now I think I see what they are. So let's go with plus 8 and minus 2. This of course would expand out to give me x multiplied by x is x squared, positive 8 multiplied with minus 2 is minus 16, and they add together to give minus 6x. So these are the correct factors, and we'll make them equal to 0. So now that you've got this, you can use, so now that you've got 2 factors and 0 on one side, you can use the 0 product rule, which means that for this side to equal 0, either of these factors have to be 0, because when you multiply with each other, if one of them is 0, the other gets nullified to also result in 0, which means that either x plus 8 equals to 0 or x minus 2 equals to 0. Now these 2 should be pretty straightforward, so I'm going to go through them quickly. We have got here, we would here move the 8 to the other side, which gives us x equals minus 8. And over here we'd have minus 2 to the other side, which gives us x equals positive 2. So having solved this quadratic equation, I'm going to put these 2 values into use. Remember that we want to find the domain of this rational function. So these x values are simply numbers of x which would not satisfy this rational function because they would result in division by 0. So I'm going to start my domain at x is all real numbers, and then I'm going to add values of x which would not work in this function. So we're going to have x and then an inequality symbol, and then we'll start with the smaller value first, which is minus 8, and then the larger value, which is x equals 2. This is the complete domain of the function r of x equals 3x squared over x squared plus x 6x minus 16. Now we are going to solve the inequality x cubed minus 4x squared is greater than 0, and we're going to express our answer in interval notation. Now I noticed that in this question, an important keyword, inequality. This means that this greater than symbol is going to be very important in determining our answer. And of course, interval notation, that is also very important. I will get to that towards the end. Now this inequality, when I first look at it, I noticed something very important immediately, that there is a common factor in both of these terms which I can factor out. And I think it would be x squared. So we take x squared out of x cubed, which is going to leave us with x. And we take x squared out of minus 4x squared, which is going to leave us with just a 4. Now we've got x squared bracket x minus 4 is greater than 0. Now for the time being, we're going to treat this inequality as if it were an equation. And here's why. We've got 0 on one side and these two factors on the other side, which means that we can use the zero product rule, meaning that x squared has to be larger than 0, or x minus 4 has to be larger than 0. And now we're going to solve each of these separately as if they were equations. However, we're going to keep this greater than symbol because it is important towards our final answer. Now x squared is greater than 0, therefore x would have to be the square root of 0 because we want to remove the x squared, turn it into an x. And square root of 0 is of course 0. So we've got x is greater than 0 on one side. Over here we have x minus 4 is greater than 0. And we want to move the minus 4 to the right side. We keep the symbol the way it is, and this becomes a positive 4. So now I've got two different answers here. But how do I express my answer in interval notation? Well, we're not quite done yet. We've got x is greater than 0 and x is greater than 4. Now we want to find all the possible values for x which satisfy the inequality. Therefore, they'd have to satisfy both of these conditions. So to graph out both of these separate inequalities on a number line would look a bit like this. X is greater than 0 would not include 0, so we'd have this curve here, and then we extend the line towards infinity. X is greater than 4 would be start from 4, but not include 4, and extend to infinity. We want to find all the possible values for x which satisfy both of these conditions. Therefore, it would have to be x equals greater than 4, because any value between 4 and this 0 would not satisfy the inequality. So this is our answer for now, and to express it in interval notation would look a bit like this. We do not include 4, so it's going to be a parentheses, and we're going to have a 4. And there's no limit saying where the inequality stops, or rather the greater bound of the inequality, so we're going to extend towards infinity. And we can't approach infinity, so we have a parentheses there as well. The final answer to the inequality in interval notation is parentheses 4, comma, infinity, close parentheses.